Hello, AT670 students. This video is just in case you want to do shadow mapping analysis and you want to do it the Blender route, or at least do the calculation component via the Blender route. You can still model your geometry in whatever package you like. This is Blender. This is the standard current 4.2.1 LTS release. So you can go to blender.org and download this and run it for Windows and OS X and Linux. I've got a slightly custom setup here, but you will have something sort of quite similar when you first run Blender. You'll have your 3D viewport here. Down here you might have, instead of this scripting window, you might have instead this timeline, and Blender has what's called a non-overlapping interface, so I can turn any window into any other kind of window. Now I want this window to be my 3D viewport, and I want this little window down here to be something which I will cover in a moment. So when you've got once you've got Blender installed and running, then you will need to go to the link that I have put in the description to a zip file for the vSuite, and the vSuite is an add-on for Blender which is going to do the actual shadow mapping for us. So once you have downloaded that zip file, and if you're on OS X, bear in mind that I think Safari has this annoying habit of decompressing zip files for you when you download them from the internet. You don't want that. You want this to remain as a zip file until we try and install it with Blender. So if you're using Safari, turn off the decompression option or use another browser, whatever. But once we've got that vSuite zip file saved somewhere, then I can go to Edit, Preferences. On the left-hand side here, I'll see a tab called Add-ons. Pick on that. And then this little upside-down hat up here, if I click on that and I press Install from Local, or sorry, Install from Disk. Click on that and this will open up a file dialog, and then I can navigate to wherever I've got to my zip file, vSuite zip file that I downloaded. Double click on that, and then you might have to wait a little while, and you will need to have an internet connection at this time, because the vSuite is now going to download automatically some libraries that you'll need, some Python libraries, in order to do all the different kinds of analyses that the vSuite can do. So your interface may lock up. On Windows especially, this can take a little while, could take 3 or 4 minutes, could be a bit quicker. But in the end, hopefully, you should have, instead of all these, you should just see the vSuite, and you should see a tick next to the vSuite. If you don't see a tick next to the vSuite, then click on this box to make sure that it is ticked. And that means then that the vSuite add-on is activated within Blender. So then what I can do, once the vSuite has been activated, is that I can now change this timeline video to a vSuite Nodes window. And within that vSuite Nodes window, you'll see I've got this button here, New. Click on New, and this will create a new node tree, vSuite node tree, with which we can do all sorts of analyses. So I'm just going to open up the example that I've got. Now that I'm going to hide because that's something else. And I'm going to concentrate on this geometry here. Now you'll see I've got, and I've only eyeballed this. This isn't accurate, and the results that I'm going to get here will be different from the results that you would get if you do have sort of decent dimensional accuracy on your surroundings. But you see, I've got the Mithras House, accommodation block, Mithras Annex, student castle, whatever. And I've got 3 blocks here. And these 3 blocks, each 3 meters high, represent 3 nominal floors. And it kind of represents the overall volume that we're most likely to be building within. So it's not a design of a building or anything like that. It's just the volume within which your design may sit. Now you could model all this in Blender, and how to model in Blender is outside the scope of this video. But you can also model it with Rhino or whatever you want to model it with, and we can do File, Import, and its wavefront. OBJ is generally the best geometry to pick. Now, when you import OBJ geometry, then there's a couple of things to look out for. If you modeled it in a package that was using millimeters, when you created the model, then when you import that model into here, it will be massive because Blender will interpret those millimeters as meters. So if you're modeling in Rhino or wherever, for example, try and remember to model in meters. If you forget to do that, there's something we can do to sort of correct it. But just to make life easier, try and remember to model in meters. And also, I've seen people, especially when importing from Rhino, they've modeled in Rhino a long way away from the center point of 3D space. So if we just think in terms of, I don't want to do that. If we just think in terms of these, you just see here this red line and this green line. This is the center of my 3D space. Every 3D modeling package has a center of 3D space where X, Y, and Z dimensions are all 0. So you want to be modeling in whatever package you're modeling in, you want to be modeling near this center point, so that when you import into Blender, your geometry will also be near this center point. So if you are modeling these blocks in another package as well, then bear in mind that the geometry can come in triangulated, and we don't really want that. So when I say triangulated, I'll show you what I mean. And I will just quickly say, in Blender you have 2 main modes. You have object mode, which you can see up here, and that allows me to sort of manipulate objects. You also have edit mode, and that allows me to manipulate elements of objects. And we can use the tab key to switch between each one. Now, if I just, or if I, in this overlay, I'm just going to turn off edge length. Now, in this model, I'm going to triangulate it. So you can see now that we don't have square faces, we've got triangles. That mesh is triangulated. We don't really want that. So if you go into edit mode in Blender and you see that this geometry of your building volumes has been triangulated, then go into edit mode with your tab key, press A to select all, press X, and then press limited dissolve. And that will make your cuboid faces just plain faces again. And then we want to subdivide into squares each of these faces. So, for example, I'm going to pick this face. Now these, when we're in edit mode, we get to pick either vertices, so that we can manipulate them, or with this menu item we can pick edges, so we can manipulate edges, or we can pick faces here, and we can now manipulate faces. So we want to be in face select mode, pick a face, and then it might be hidden by default, but if it is hidden by default, you'll see this little tiny icon up here. Click on that, go to the vSuite tab here, and when we're in edit mode, we should get this grid the object option here. Click on that, and that will just create a square grid on that face. Pick that one, do it again, pick that one, do it again, and just pick that one, do it again. So these subdivisions are going to be then the places on the mesh where we sample the probability of sunlight. So now, I would obviously do the same thing for the next 2 floors below. I'm not sure I'm going to bother with that here because I want to keep this video quick if possible. So that is fine. You can set the spacing of these grid elements with, again, this might be hidden by default, but when you hit this grid the object button, you should get this little panel, and you can set the size of the grid, but I'm just going to stick to 0.6 meters and 0.6 meters, which is the second and third option. So that's fine. Now, you'll probably be, whatever 3D modeling package you use, you'll probably be familiar with the idea that objects or geometry has materials associated with it. So these are the properties panels in Blender. Our render property panel, our world property panel. This is the object property panel. And this red globe here, that is the material property panel. So for the currently selected object, I click on that and it will tell me what material is associated with that block. If there is no material associated with the block, then I would hit plus here to create a material slot. And in fact, if I do that now, if I remove the material from that object, I hit plus to create a new material slot, add new material to that material slot, give that a whatever name I want, top floor sensor, and then in the vSuite material section, you turn geometry into light sensor. That then specifies that this object is a light sensing object. Everything else in your scene, or your surrounding buildings and everything, they should too, or in fact must, have a material associated with them, but that material type we keep at the default of geometry. So I think that's kind of like the basics of the very, very quick run through of the basics of the geometry and the materiality. So now if I come down into my vSuite node tree, I'm not going to do a sum path analysis here. Get rid of that for now. Get rid of that for now. For a shadow map, we need 2 nodes. One node to tell us where in the world this project is, and another to do the actual shadow mapping for us. So if we add input nodes VI location, this will give us a VI location node, and the default latitude and longitude is more or less Brighton, as close as we need to care about. So you can keep all these options as they come by default. We also then need an analysis and add analysis nodes shadow map. Connect the location node into the shadow map node, and we now have some options. First option is ignore sensor. This means that if I click this on, the roof of this second block won't see the top block, because the top block is a sensor and we are ignoring the sensor, and you want this turned on. Animation, we're not going to do a parametric analysis here, so we'll keep that at static. Start day of the year defaults to 1st of January, and end day of the year defaults to 365 or the 31st of December. Start hour, the start of the beginning hour. So start of the 0th hour is midnight, and the end of the 23rd hour is also midnight. So that's the whole 24-hour period. So this is simulating the whole year for the whole 24-hour period. I can then break up each hour into a number of steps. So I can do every day, I can do 1 simulation per hour, or 24 in a day, or I can do 1 simulation per half an hour, or 48 in a day. You get slightly more refined results the higher this number, but it takes longer because we're doing more simulations. So for the purposes of this, I'm just going to keep it at 1. Keep your result point at faces. Keep your offset, maybe set that to 0.01. And that's basically it. So now I press calculate, and we'll get a little window up that will tell us that we're calculating away. This should not take very long. There's a cancel button here should we need to stop for any reason and do something else. And then in the same window that we had before, in the same vSuite tab that we had before where we were gridding the object, we now have this shadow display option. Click on that and you'll see now that we have our coloration for the percentage of sunlight hours that hits the building. Now I might just turn off display for a moment. I'm just going to increase my offset a little bit, 0.001, and do that calculation again. Because I've wrapped my whole building in a skin, then I'm getting some distortion on the results plane. So put this at 0.001. So just wait for that to complete again. So there we go. So the legend here, we click on this, opens a legend. If we put the mouse over the top left, we can move this legend around. If we put the mouse over the bottom right, we can scale this legend. So by default, we get the percentage of hours that the sun hits a particular point. And the hours that are available are the hours that the sun is above the horizon. So at night time, when the sun is below the horizon, we don't count that. We're only counting the hours that the sun is above the horizon, and this is the percentage of those hours that these points are getting direct sunshine. So, yeah, you can see here, this gets the most, fades off a little bit down to sort of 50% or so as we get closer to the retaining wall here at the back. Our westerly facade is getting maximum about 30 or so, minimum very low down here at this corner. South face, again very low down here and along here, a little bit more up in this corner. And our north face, as you might expect, a little bit in summer, I think, coming around on this corner, but otherwise basically zero. Now we have some, once we pressed shadow display up here, we've got options. So we can change the name of the legend up here. Sorry, we can change the result type that we display. Shadow mapping by default just gives us percentage sunshine, which we've got. We can change the name of the legend. Ooh, hello, if we want to, but you can generally leave that. Automated processing, unless we're doing some advanced analyses, we can keep that at none. Frame, that only applies if we had an animation parametric simulation. Keep that at the default. We kept this legend max, legend min, that defaults to the maximum value and the minimum value. So I can change this to change my coloration if I want. So if I was doing a number of different simulations, a number of different scenarios, sometimes I might just make sure that each time I set, for example, legend max 100, legend min 0, and then my whatever coloration I've got across my different simulations, it'll all be consistent because they're all working off the same coloring scheme. Legend scale, you can leave that as it is. We can change the color of our visualization as you wish. And emitter materials we don't need to worry about. Draw wire will just, if we have something selected, this will just toggle whether we turn on the wireframe on that object or not. Transparency, that's just in case we want to sort of grey out our and allow them to be a little bit see-through, but generally you can leave that as completely opaque. And point visualization is important. So point visualization, that will turn on a number for each of the planes. Now by default, selected only is off and visible only is off. So that means that we'll get a number for each calculation point, irrespective of whether we can actually see that calculation point. So all the numbers for the floors below are visible, even though this floor is in the way. If that's the case, turn on visible only and just move that around a little bit. And now we can see that we've got numbers associated with each of those calculation points. We can change the font size of those numbers. We can change the font color, font shadow. If you get some numbers that don't appear, increasing this position offset can sometimes help with that. And I mean, that is a super quick rifle through. Obviously, I can't really cover how to use Blender here, but there are millions of video tutorials out there that will just tell you in half an hour or whatever the basics of manipulating the 3D environment, doing very basic geometric manipulations, etc. And so I'll refer you to those just for the basics of how to initially interact with Blender. Once, as I showed in the session today, these can all be moved away. And they can be offset, so we can see if we want each individual floor, each individual roof of each individual floor, etc. So do have a play around with the best way to show off the results, best way to communicate what it is you want to say, best way to highlight to the reader or the viewer of your work how this is the beginning of a story of a kind of solar-based environmental design. You should be, if you want to, you should be able to select these objects and you should be able to export them from Blender also as an OBJ. And in theory, Rhino should be able to open these up with the colors. You will probably, this legend is a feature of the Blender window. So you might want to screen grab this and crop this so that you could get your color legend in whatever other application you want to use. I will also just say quickly, obviously we can do just a winter analysis here where we're thinking very much about solar gain and we're probably wanting as much sun as possible. We could do a summer analysis where we could be thinking about too much solar gain, the building potentially overheating. And so we might ultimately be thinking of ways of reducing that solar penetration, at least into the building through any glazing or transparency we might have on the building facade. If we were to pick the morning, so if we did a simulation for the first half of the day, that's about the morning sun. Again, that could be a story about how well light is penetrating and heat is penetrating into the space to help warm it up in the morning. If I did this from 12 to 23, just doing a simulation in the afternoon, again, it's about how much solar are we getting, how much sun is landing on the sort of nominal surface of the building, and do I need to be careful about that in terms of where I put glazing in my building so that I don't overheat my building in the afternoon when buildings are most likely to overheat anyway. Annual analyses good for solar power, give you a sort of quick estimate as to where might be worthwhile in terms of solar PV power production, etc. But you know, these are narratives that you can tell, these are stories that you can tell. The trick is to pick an analysis, to construct the experiment, to construct the simulation, to best enable you to say what it is you want to say, to best enable you to have that once upon a time moment for whatever sort of technology design story you want to tell. Okay, I really do think that's it now. When you're done with visualizing, always try and turn off the display active option down at the bottom here. That will just turn off everything and reset everything to a simulation ready state. You can render the scene out in sort of a professional way, but that requires cameras, and again, I would refer you to Blender in terms of doing that. But we can save screenshot, and that will just save a screenshot of this window, or you can use your computer or your operating system's screen capture functionality to give you whatever images you need from the 3D viewport. Now I keep thinking I've said everything, and then I keep remembering something, but I think I really have now said everything I need to say. Okay, cheers then. Thanks for watching. Bye now.